Hey guys, this is Hartuk, and in this video we're going to talk about how to reverse a linked list. Just another use case for a linked list that I think will really solidify you guys' understanding of how to use them. So let's just hop right into it. So essentially over here we have an example where we have the values 1, 2, 3, and 4. And so in a regular linked list, the 1 links to the 2 links to the 3 links to the 4, and the 4 eventually links to none. And then I just put the none over here just to emphasize the fact that before the head node, there's nothing there. It's just, you can imagine that there's an imaginary null value. And when we reverse the linked list, you guys can probably guess, all we do is basically we reverse all these next pointers so they point in the opposite direction. So now self.head is actually 4, right? Before is the end of the list, now it's the front of the list. And then that points to the 3, that points to the 2, that points to the 1, and eventually the 1, which was previously head of the list, now points to nothing. So essentially, our last values become our first values, and our first values become our last values. So we'll just hop right into it and see how to code. Over here, I have these values a, b, c, d, and e, and then we call this function called reverse, which is over here right now, and we'll just implement it right now just to see how that works. So the main thing that we're gonna have to do is we're gonna have to figure out how to store the previous nodes and how to reverse these next pointers. So what we can do is we can start off with, we're gonna need a reference to the previous node. We're gonna have a current node and a previous node and a next node. So essentially we'll start off with previous node equals none, and then the current node equals self.head. And what we can say is that while the current node exists, so basically while we're not at the end of the list, what we can do is we can store the next node after our current node. So our next node is equal to current node dot next. And the reason why we want to do this is because if 2 is our current node, what we want to do is we want to reverse the next pointer for 2. So instead of it pointing to 3, it points to 1. But the problem is after we change this pointer, because the next pointer now goes in the opposite direction, we can't update the next node after we've changed the next pointer. Otherwise, we'll go right back. We'll come from the node that contains the value 1, and then after the next pointer is changed, we'll go back to the node that has the value of 1. So instead, what we need to do is we need to store the next node, which is 3, so that we can progress ahead in the list. So it will make more sense as we go through it. So basically, what we can do is we can say that the current node dot next is equal to the previous node. So in this case, what we're doing is if 2 is the current node, we store the next node, which is the node with the value 3. We store that. Then we say that the current dot next, this node's next pointer points to our previous node, which is the prev node. And then what we do is now we need to store the prev node, and we need to say that this is the new prev node. Well, what we could have done prev equals cur.next, but we can't do that anymore because cur.next is now the actual prev node itself. So what we have to do is we have to do prev equals cur. So essentially what this will do is that 2 is the current node, then we store the next node, which is the node 3, which is the node that contains the value 3. 2 in this line of code, 2 points to the node with the value of 1, and then in this line of code, we take the prev pointer, or the prev variable, which is originally the head node, with the value 1, and we make it equal to the node that has a value of 2. And then we have to update the current node, so we do say that current node is equal to the next node from before. So essentially what we do is we take this node, that was a current node, and because we stored the next node with the value of 3, we just move the cur pointer from here to here. And at the end, what we need to do is because we reverse the linked list, originally the node with the value 1 is the head node. Now the node with the value of 4 will be the new head node. And since we continue the while loop while cur exists, we know that when cur stops existing, we're going to be at the end of the list. So our prev node is going to be the last node in the list. So because of that, we can say that self.head equals prev. So if we test this out, right, we have the values here. We can just print it out. When we print out the list the first time, we'll have the values A, B, C, D, and E. And then when we reverse the list and we print it again, we're going to have the values E, D, C, B, and A. So let's just test that out. And let me actually break this over here so that's a little better too. So do that one more time. So we can see over here the values are A, B, C, D, and E. And then over here we see that we start with E and then go backwards. So we have E, D, C, and A. So hopefully the main concept that you guys get from this is that what we're doing is we need to update the next pointer of every node. And so in that way, the last node becomes the first node. That's it for this video. Thank you for watching and see you in the next one. Peace.